Advanced algebraic fraction simplification. So we want to simplify each of these. Now, this first couple just here are fairly easy. We're just using the index law that a to the power negative n is the same as 1 over a to the n. So with this first one, where we have a to the negative 3 on the bottom, so the n is negative 3, the negative of negative 3 is positive 3. So that's just going to be a cubed. We're following exactly the same thing here with the b. So we have that the n is 4, and therefore negative n would be negative 4. So that would be b to the power negative 4. Now when we come to this example, we're going to need some other index laws. ab to the power n is a to the n, b to the n, and also that a to the n, then to the power m, is a to the n times m. So if we look at this part here, we can use this index law. So the a squared is just going to sit there for the moment, and then the b cubed needs to be to the power 2, as does the c to the negative 1. And all of that is squared, and it's all over a, b, c squared. Now we can apply this index law just here and here, and we get a squared times b to the 6 times c to the negative 2, all of that is squared, all over a, b, c squared. Now we use the two index laws again, but I'm going to use them both at once. So the a squared here will end up being a to the 4. The b to the 6 will end up being b to the 12. And the c to the negative 2 will end up being c to the negative 4. All over a, b, c squared. Now we have another index law to use, which is a to the m divided by a to the n is equal to a to the m minus n. So a to the 4 divided by a to the 1 is a cubed. B to the 12 divided by b to the 1 is b to the 11. And c to the negative 4 divided by c squared, negative 4 take away 2, is c to the negative 6. Now, depending on the situation, we might leave it there or reapply this index law here to write that as a cubed b to the 11 over c to the power 6. Now when we look at an example like this, it looks really complicated to start with, but it's just a case of being very systematic and working through bit by bit. So if we look at the top of this fraction, there's nothing at the moment to do with the 3p squared and the q. From what we've done previously, we can see that this is going to end up being r to the negative 2 t to the negative 4. And there's nothing much to do with the bottom of this one. So 4p q to the negative 2. Now coming to here, the 8 is inside the bracket, so it's going to get squared. The pq squared to the negative 3 is going to get squared as well. So let's just write that as pq squared. Negative 3 times 2 is negative 6. And then we'll have r squared t squared. On the bottom, there's not too much to do with the 9pq at the moment. Then all of this is to the negative 3, so negative 1 times negative 3 is 3, so that would be r cubed. And then we'll end up with t to the power 6. Now, before I go ahead and start simplifying, I'm going to just rewrite the whole thing down, except for this bit here. I'm going to sort this bit out. This is the only bit that needs to come out of a bracket. So we've got 4p q to the negative 2, and then we'll have 64 p to the negative 6, q to the negative 12, r squared t squared over 9 pq r cubed t to the 6. Now this 4 can cancel with the 64 to make that 16, and the 3 and the 9 can cancel to make this a 3 on the bottom. So looking at the top, when we multiply the two tops together, we'll end up with 16. Think about the p's. We've got p squared and p to the negative 6, and when we multiply we add the indices, so that will end up being a p to the negative 4. For the q's, this is a q to the 1, remember. Multiply that by q to the negative 12, so that's going to be a q to the negative 11. The r's will add the indices. Negative 2 add 2 is 0. Now normally I would just not write that down because obviously that becomes 1, but in this case I am going to, because we've still got r's on the bottom, so I'm going to write that as r to the 0. And then here negative 4 add 2, so that's a t to the negative 2. On the bottom we have a 3. P times p is just p squared. Q to the negative 2 times q is q to the negative 1. And then we've got r cubed and t to the 6. So 16 on the top, still got a 3 on the bottom. Now we're dividing, so subtract indices, so that's going to be p to the negative 6. Negative 11 take away negative 1 becomes negative 11 plus 1, so that's q to the negative 10. 0 take 3, r to the negative 3. Negative 2 takes t to the negative 8. Now, that might be an okay place to leave it normally. I'd probably move the 3 over to the middle of the fraction there. But very often we need to write these things without negative indices, so the only thing left on the top would be the 16, and then we'll have 3 p to the 6, q to the 10, r to the 3, t to the 8. Now, very similar to the last example, except we're dividing fractions here, which means this one needs to turn upside down, and then we change the divide to a multiply. So let's look at this one. Applying index laws, we've got 10a to the 4. Then we're going to have b squared c to the 4. There's nothing too much to do with the bottom of this one. 3ab to the negative 4. And then we're multiplying by, let's turn this upside down, 12 ac b to the power 6 all over 5 a to the 6 b to the negative 3 c all squared. Now we can do some tidying here because we can subtract indices. Remember, this is a to the 1. So I've got 10 a cubed, 2 take away negative 4 is 6, c to the 4 over 3. And then here we've got 12 a c b to the 6 all over 25, 5 squared, a to the 12 b to the negative 6 c squared. Now 5 goes in here twice and into here 5 times. 3 goes in here once and goes into here 4 times. So we have 2 a cubed b to the 6 c to the 4 over 1 multiplied by. So on the top here we've got a 4. Then if we subtract the indices here, we'd have an a to the negative 11. Subtracting indices with the b, so we've got 6 take away negative 6, which is 6 add 6, so that's b to the power 12. C will be to the power negative 1. And all of that is over 5. So multiplying now, we have 8. Add the indices, we get a to the negative 8. b is to the power 18. c will be to the power 3. And all of that's over 5. And if we want to express that without any negative indices, it's just the a that needs to come to the bottom. So 8 b to the 18 c cubed over 5 a to the power 8.